Hello class, and welcome to section 4.3, which is about writing equations in point-slope form. Again, we are going to split this lesson up into 2 days. Today's focus will be writing and graphing the equations in point-slope form and how to convert from point-slope form back into our slope-intercept form. First, point-slope form, the equation is y minus y1 is equal to m parentheses x minus x1. Just as in slope-intercept form, that m value stands for our slope. Our y1 over here and our x1 over here come from the point x1, comma, y1. So instead of going through and finding a b value, we can just plug in the points immediately into this equation. Notice the equation starts with minuses. So y minus y1 and x minus x1. So you need to be very careful with those minus negative signs. So, for example, our first problem here, we're going to write and graph the equation that passes through the point negative 2, 1 and has a slope of negative 6. Again, a reminder that that equation was y minus y1 is equal to m parentheses x minus x1. So I'm going to go ahead and label this x1, y1, and my slope is m. So now I'm going to go ahead and plug in my information. So y minus 1, because 1 is my y1 value, is equal to m, which is 6, parentheses x minus negative 2, which gives us our point from our x1 value. Minus a negative turns into a positive. So our equation is y minus y1 is equal to, y minus 1 is equal to negative 6, parentheses x plus 2. So that is our equation portion. When I am going to graph, I always start my graph at the point that they give me. So my point is negative 2, so over 1, 2, and then up 1. So my starting point is this point right here. Then I'm going to go ahead and use my slope. We're going to turn it into a fraction, negative 6 over 1. So we're going to go down 1, 2, 3, 4, 5, 6, and to the right, 1. So that second point, we started at our first point and used the slope of going down 6 and right 1. Then I am going to go ahead and connect those points using a straight edge. And you are going to have a line that ends up looking something like this, making sure it covers the whole graph and has those arrows on the end. Go ahead and try this one on your own. You're going to type the equation into the answer box, and then you will view the graph once you are completed. So your equation is y plus 3 is equal to 5/7 parentheses x plus 6. That starting point, we are at negative 6, down 3, and then we're going to come up 5 and over 7 for that second point. One other thing to pay attention to is if it asks you to graph a horizontal line. A reminder that a horizontal line has a slope of 0. So your equation is going to say y minus y1, which is 2, is equal to slope, which is 0, parentheses x minus x1, which is 7. So writing the equation is the same. Graphing starts the same, so we're going to go over 7 and up 2. And then when it asks for a horizontal line, all you have to do is go ahead and draw in that horizontal line. So that's just one kind of slight difference. The only one that will have this case is if it asks for a horizontal line. The other thing that we're going to do today is convert from point-slope form into slope-intercept form. So a reminder, your point-slope form is y minus y1 is equal to m parentheses x minus x1. Your slope-intercept form is y equals mx plus b. So we are going to turn this equation into this sort of format. So for example, we're going to start with y plus 6 is equal to negative 3x minus 4. 4. We're going to take our point-slope equation and rewrite it into slope-intercept form. Your first step here is going to be to use the distributive property to get rid of the parentheses. Slope-intercept form doesn't have parentheses, so we want to get rid of that. So we've got y plus 6 is equal to negative 3 times x, which is negative 3x, minus negative 3 times 4, which gives me negative 12, or you can look and see two negatives are going to make a positive. So now we've got y plus 6 is equal to negative 3x plus 12. In order to get in y equals mx plus b form, we need this y value to be by itself. In order to do that, we're going to have to get rid of the 6. So we are going to subtract 6 from both sides, and I end up with y is equal to negative 3x plus 6. So our two steps we did here was distribute to get rid of the parentheses, and then we subtracted 6 to get the y isolated by itself. Go ahead and try this one on your own. Again, distributing 5x plus 50. To get rid of negative 16, you're going to have to add 16 to both sides, giving you y equals 5x plus 66. Process is similar when there are fractions involved. Again, you are going to start by the distributive property. So I've got y minus 3 is equal to 2/5 times x, which is 2/5 x, plus, I'm going to do this off to the side, we've got 2/5 times 5, which is going to be 5 over 1. So I'm going to go ahead and multiply the tops and get 10, multiply the bottom and get 5, and 10 divided by 5 gives me plus 2. Then I'm going to go ahead and get rid of my subtracting 3 by adding 3 to both sides, and my equation is going to be y is equal to 2/5 x plus 5. Go ahead and try this one on your own. Distributive property of 1/3 and then adding 3 to both sides gives me y is equal to 1/3 x plus 1. If you have questions about this or anything else from the lesson, please let me know when you get to class.